welcome back to the EdSurge Thought Leader interview series about the future of education. We are live from the, I'm Jeff Young, an editor of EdSurge, and we are live from the ASU+GSV Summit in Salt Lake City. And I'm excited we have Candace Thille from Carnegie Mellon, originally in the Open Learning Initiative, and now at Stanford University's Graduate School of Education. And I'm excited to talk with you about your pioneering work in using big data in education. Thank you so much for joining us today, Candace.
Thank you for inviting me.
So you were doing adaptive learning before it was cool. And I wonder, we're getting a little bit of feedback there, but what is it that got you interested in adaptive learning? Pardon us for this. We had a little technical issue, but now we got it. Okay, so just what got you into this, you know?
Okay. So the Open Learning Initiative, which is the project that I founded at Carnegie Mellon, started with a desire from the William and Flora Hewlett Foundation to give access to high-quality post-secondary education to those who would not otherwise have access. And their first big project in that space was MIT's OpenCourseware.
Sure, that was way back.
It was way back in 2001.
Great.
And they came to Carnegie Mellon looking for other schools that would be interested in putting all of their course material online also to provide that open access. And, well, two things. At Carnegie Mellon, we're never going to do anything that's a derivative work of something MIT is doing.
Right.
But we also had a different idea to propose. And so Mike Smith and Kathy Casserly came and listened to the idea. We're not interested. We're about to leave. But the day they were visiting was September 11th, 2001.
Wow.
So they ended up spending 3 days in Pittsburgh that they hadn't planned on spending, which gave a lot of time to talk through and really understand what their interest was. And their interest was to find some way to provide access to high quality education. And our argument was high quality education is more than just putting the materials that support education online and making them available. That actually there's a lot of pedagogical knowledge that has to go into how you teach someone something. And so we came up with the idea of the Open Learning Initiative, which was to take the decades of research that had been done at Carnegie Mellon in intelligent tutoring systems and blend that AI perspective with disciplinary experts, with the idea of open content, with the affordances of the technology to make it available to create the OLI courses. And so we didn't say we were going to put all of Carnegie Mellon's courses online. We started with just 4. And so we started collecting the data, actually, because we recognized that we would never see the learners that were supposed to be benefiting from this. And so we wanted to just get some insight into, is there any evidence that these environments that we're carefully constructing based on what we know about human learning are actually supporting learning? So we started collecting the data for that purpose. And then about that same year when we started OLI, we applied for an NSF grant for a Science of Learning Center, in the recognition that this data that we're collecting is not only good for understanding whether the environment is supporting individual learners, but also it can give us insight into human learning. It's a great research environment because we can put these designed interventions, meaning interactions that you're having a learner do. And I think of designing every piece of educational technology as a hypothesis. So based on what we think we know about human learning, based on what we think is difficult about this concept, based on what we think we know about the learner, we're going to have the learner engage in this action. And that's our hypothesis, that action will help them move from where they are to where we want them to go. But we can collect the data to both refine the educational technology itself, but also refine that hypothesis, i.e. Increase our understanding of human learning, feed the science of learning. So that's how I sort of got interested in this space and how OLI became both a platform for instantiating what we think we know about human learning, to use that to support learners everywhere in the world, but also as a research environment to continuously collect data to refine our understanding of human learning.
And that goes to my next question, which is more recently, it seems like you've raised some concerns about that, it's not always a research environment where some of these tools are getting developed for adaptive learning. And then in some cases, it's companies building products which become kind of black boxes in your view. And could you say a little bit more about your concern about how the corporate kind of aspect of the way this trend, now that it has become a thing, to do adaptive learning, how that is how the trend is developed?
Okay, sure. And thank you for asking that question, because I think oftentimes when my work is presented in the press, sometimes it is argued that I'm anti-business, and I think that the commercial sector shouldn't be in this space, all that kind of stuff. And a lot of people don't realize that before I became an academic, I was for 18 years in the private sector in a strategy and management consulting firm. So I'm very supportive of business. I understand how businesses work. The other thing that people often say to me is, Candace, you're just thinking about the unethical startups out there. And there are a lot of startups that are incredibly ethical. And so, you shouldn't sort of paint them all with that unethical brush. And my response to that is, I completely believe that most 99.9999% of the educational technology companies out there are ethical. Like, that's not a question to me. And I believe they are truly trying to create products that support learners and attend to challenges in education. I also know from being in the private sector that the number one driver has to be, when you're a for-profit company, returning shareholder value. And if you are not taking that as your primary driver, then you are behaving unethically. So it is not that I don't think people are ethical. It is that I think there might be a conflict between the primary ethic that has to drive you when you are returning shareholder value and meeting needs of the public good. I mean, it's sort of the reason that blood banks, when we developed blood banks, the decision was made years ago not to pay people to donate blood, not to have them be for-profit entities, because the state of the need of the public good was a bit in conflict with what they would become if they were totally driven by markets. So do I think that markets have no place in this? Absolutely not. Mm-hmm. I think that there's going to be a big and robust place for the commercial and private sector. I just think that we haven't figured out yet a functional and productive relationship between the private sector and not-for-profit higher education to really drive the development of these technologies in a way that will sort of maximize the public good.
I think one of the interesting ways I understand your critique, and correct me if I'm wrong, is that one of the things you're arguing is that these algorithms that underlie these tools of adaptive learning that are going to deliver this instead of that as you're going through these course modules is kind of the core part of the academic core in the future.
Oh yeah, okay.
That we're outsourcing.
The idea that we're outsourcing our core business process.
Yeah.
Yeah, and that is something else I got from being in the private sector. Is one of the core tenets of any business is you do not outsource your core business process. And I think we have in higher education gotten into a pattern of outsourcing material development to
like the
textbook so that's a classic example. And people are perfectly fine developing their courses, buying large textbooks or asking their students to buy large textbooks and then just selecting stuff out of that they're going to use as set of foundational material to teach from. And so at that point, when you're using textbooks in that way, still the pedagogical decision making is still being made by the institution or by the faculty member. The challenge with these environments is that they are, in essence, making pedagogical decisions. Mm-hmm. So if you design an environment to support a learner to achieve some outcome, and then you're collecting the way the student is interacting with that asset, collecting that data, and then hopefully doing something more sophisticated than just did they get it right or wrong, but actually modeling it in an appropriate way to be able to make a fairly accurate prediction about the learner's knowledge state. Then you can do one of two things with that piece of information. If you're the system developer, you can take it and feed it back into the system so that the system can start making autonomous decisions about what's best for the learner next. Or you can do what we were doing in OLI, which was take that information, model it, and then present it to the faculty member who's teaching the course so they can get insight into their learners or their class's knowledge state, and then use that to make a pedagogical decision. But whichever way it is, you're essentially, the system is making a diagnosis. Mm-hmm. It is making a pedagogical decision. And the science is such, I would argue, that to make really good diagnoses and really good pedagogical decisions, people are going to probably shout at me for this, the science isn't robust enough yet to commodify that. And what I mean by that is learning is really complex. It's not, we think about recommendation systems like from Netflix or Amazon. I don't know if I'm allowed to mention commercial people, but they're recommending to you what movie you should get next, what product you should buy next. And I don't know, I'd be interested in the audience out there, how often you think they get it right. And if they get it wrong, you kind of like, oh,
the stakes aren't high.
Yeah, stakes are high. Yeah. And by your saying, oh no, that's wrong, then it will adjust and it'll try and get better and better, learn more and more and more about you, so it gets better at recommendation. The decision about what a learner needs at any point in time to be able to achieve some learning goal, that decision is a complex interaction among factors about the learner, and they could be traits, they could be states. What's my knowledge state? What's my sense of belonging in this environment? What's my identity about myself? How does this particular knowledge play into my identity about myself? What do so many things about the learner that are material to thinking about how to present, how to support that learner to learn something. And then the knowledge that we're trying to have the learner learn at any given point in time. Like, am I trying to help the learner become more fluent at something that they kind of already know and you just want them to develop fluency? Or am I trying to get them to understand some complex principle that they really my goal is for them to make meaning. So there's all kinds of different knowledge that would indicate that a different kind of instructional move would be different. And then what's the context in which that learner is learning? And those, at least those three things, interact in very interesting ways that would support an effective pedagogical decision. And one of my hopes about the technology is that, our brains are not really good at handling multiple dimensions of information to try and make a decision. Our brains aren't that great at handling real complexity. So what we do, the way we historically do that, is we reduce it. We manage complexity by reducing it to something we can manage, so we can represent it to ourselves in a way that we can manage it. One of the big powers of the technology and of the new data science tools is a computer can manage many, 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 many more dimensions of complexity and represent it in a way that we can understand, so we can manage the complexity without having to reduce it. Mm-hmm. And that's but that decision about how you go about taking many, 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 many pieces of information and creating some kind of model that makes it manageable, that is a decision. Right. And that's where a lot of bias can be introduced into these algorithms. A lot of people, I think, make the mistakes of thinking, oh, if a computer's doing it, it's objective, it's unbiased. No, I mean, it's going to be biased either by the person who made the design decisions in designing what features to put into the algorithm, how to weight them, all kinds of which algorithms to use. Mm-hmm. Those are all decisions that have an impact on what that algorithm is going to produce. Or you could say, well, yeah, that's fine for the ones where people are designing features, but what about sort of pure machine learning algorithms, unsupervised, where we just give them huge amounts of data, give the algorithm a huge amount of data and just say, you figure it out. We're not going to tell you what's important to look at. You tell us what's important to look at. But there again, you're going to introduce bias by the data that you give it. And also, if the data has inherent in it a decision-making process, then the patterns in that decision-making process will be replicated by the machine learning.
So it seems like the stakes are high and the problem is so hard. How do you, is it still just too soon? Is it need to be in your view, a research project still before it gets to be kind of products? Is that the idea?
Yeah, I think, and that isn't to say that we should stop making products.
Sure.
It's just that we shouldn't make products with false assurances. And we should acknowledge that this is a really active and interesting frontier of science we're on. And so that's why I said what I think we need to do is figure out more functional, productive relationships between not-for-profit higher education, commercial developers, and within not-for-profit higher education, even a much more functional relationship between researchers and practitioners. And I think that is, I don't think we have that figured out. But I am, to any ed tech developer out there, any researcher out there, any practitioner out there, I am interested in talking to you so we can try and figure this out.
Right. Come visit you at Stanford.
No, actually, no, wrong. No.
Well, I wanted to ask you about, you are working with other colleagues at Stanford that are in other areas, like that are understanding the kind of psychological components of learning and other things, like Carol Dweck, who a lot of our readers or viewers probably know. Can you tell us a little bit about that work and maybe a promising, in your view, example from your collaborations at Stanford?
Sure. Yes. One of the, at Carnegie Mellon, I haven't abandoned Carnegie Mellon. I still work very closely with my former colleagues at Carnegie Mellon. So that's still because Carnegie Mellon has a depth of expertise in the cognitive science and the stuff we've just been talking about. At Stanford, I got a whole new host of colleagues.
Sure.
Carol Dweck is one of them, Jeff Cohen, folks that are looking at other aspects that are material to human learning. Carol, as you mentioned, works on mindset. So, and the idea for, just briefly, and I'm going to totally simplify a complex idea, is that learners can either have a fixed mindset or a growth mindset. If you have a fixed mindset, then you fundamentally believe that intelligence is fixed, that it's something that's innate to you, that it can't really be changed. And you can hear students say things like, "Oh, I'm just not a math person. I've never been good at math. I'm just not a math person." And so when they confront then, like in our open statistics course, when they confront a really difficult concept in statistics and they struggle and they don't get it, then the meaning that they'll give to themselves is, "Oh yeah, I know. That's because I'm not good at math, so I can't do this." And so if you have that kind of fixed mindset, you don't really believe that you're going to learn from engaging, then why torture yourself? Just kind of either just try and memorize it so you can get through, or just stop engaging with it. So if you have a growth mindset, though, you recognize that actually that's not how your brain works, that your brain gets strengthened through struggle. So when you confront that really challenging statistics problem and you try and you get it wrong, then instead of saying, "Oh yeah, I can't get this because I'm too stupid," you say, "Oh, I didn't get that, but I made my brain stronger. So I'm just going to keep struggling, and eventually, if I keep working at this in a productive way, then I'll get it." So what we started to do in the OLI statistics course, and we have partners at multiple Carnegie classification of institutions. So we did some experiments introducing mindset interventions into the courseware, so that learners, in anticipation of when you're taking a statistics course, you're going to run into these places. And if you think that you can't learn it, you're going to stop. So can we first educate you a bit about how the brain works, and then do these booster interventions, remind you about the mindset idea right before you do something that's really challenging. And we did get a positive result we did it as an experiment. So some students got the mindset intervention, some didn't. And students who did get the mindset intervention did persist longer and learn more, which is good. But, we still want to keep learning more. So we are in the process now with another colleague, Ryan Baker, who used to be at Columbia and now is at Penn. He builds affect detectors. So in the data stream, can we not just tell what's cognitively complex, but also what's the affective state of the learner? Are they confused? Are they bored? Are they angry? So so we're building these affect detectors into the OLI courseware so that we can time the intervention of the mindset intervention, not only to the cognitive complexity of the task, but also to the affective state of the learner.
And this is an example of what you're describing, I guess, of using the power of building the algorithm to try to make a teaching decision.
Yes.
Well, I have one other question, and then we are starting to get good questions from our audience too. I'm going to open it up to the crowd right after this. But I was really curious because it seems like we've all had a great teacher, right? A formative moment because somebody, taught us the old-fashioned way, and we had a great moment.
Yeah.
I wonder, is it possible, do you think, in some distant future, that someone might have one of those types of experience from an AI adaptive learning kind of machine?
So I guess it depends kind of on the experience you're talking about. I mean, and I also want to, the other thing that when people write about my work, they often put as a big headline, she's trying to replace us with computers.
Sure.
And the us being faculty or teachers. And I just want to assure everybody, I am not trying to replace anybody with a computer.
Sure.
What I am trying to do, what I think about designing a learning environment, I think about that there are multiple resources you can bring to bear. There's what a learner can do with a computer, and I'm trying to make that as good as it can be. There's what a learner can do with their peers. There's what a learner can do with an instructor or an expert or a human person who knows more than they do who's trying to support their learning. And all of those resources have their affordances and their limitations. And so when designing a learning environment, I always try and think about how can we blend those affordances to best support that learner or that group of learners in that context at that point in time. And the technology piece should be designed not just to support what the learner is doing with the technology, but also support the other human actors in the system. So giving the expert or the teacher or the faculty member or the caretaker the best information we can give them so that they can best do what they do best to support the learner. So do I think that a computer will completely take away from any need for any kind of human, whether that be a peer or a teacher? No. But I do think that we can use the technology to make the role of the other humans much more effective. I will say, though, that when we were designing the OLI courses back when I was at Carnegie Mellon, one of the things we did was really unpack when a student would make a move to try and make an inference based on what we collected about their knowledge state to that point in time, and also the move that they made. We could make a pretty good inference about what they were thinking when they made that incorrect move. And so we started to have the feedback keyed to that. So we would create these taskings and then give them feedback that would say something to the effect of, so this part of your thinking was square on, and you were doing this because of this, but you probably did this because you were thinking that. And this is where that's not the way you should be thinking about this. And I would have people come up to me, and students come up to me and say, how did the computer know what I was thinking? And so they had that experience in some ways of being, of at least cognitively, being seen and supported based on where they are.
Because of the data and the
algorithms. Yeah.
Well, we're running near end of time, but I definitely want to get to, we have, I think, a video question out there. And if others want to jump in, there's a hand icon at the bottom of the interface on this Shindig platform, and you can press that. And you can also do the question mark text in the future. But first, we're going to go to Ray. And it just takes a second here to pull Ray up on to ask a question of Candace Thille.
Do I look at the screen or you?
I think the screen at this point. Hey, yeah, Ray's coming online. Hey, Ray.
I can't hear him.
He's muted. Let's see. Can you hover over your video and click?
Have I done that?
Unmute. There we go. That's better.
Can you hear me now? Yeah. Okay. My question was, yesterday the Carnegie Mellon work was brought up by one of the other presenters from, I think, Maryland. And that book was How Learning Works. And and so I was just wondering, that was from 2010. Are there any more updated works that go through the details of your work there at Carnegie Mellon or maybe Stanford?
Great. So yeah, that book, How Learning Works, was a book that was written by my colleagues in the Eberly Center for Teaching Excellence several And it's a really great practical guide for people who are trying to think about how to design learning environments. That was mostly classroom-based learning. Another book that I would recommend from my colleague at Stanford, Dan Schwartz, who's actually the dean of our Graduate School of Education. He just recently published a book called The ABCs of How We Learn. And that is 26, as you can guess because it's ABCs, 26 research-based principles and sort of instructional strategies. And it goes through, it's written in a similar way, targeted at practitioners, where it will talk about what's the core mechanic, because he thinks about it in terms of like that kind of game narrative. What's the core mechanic of learning? And then what's the instructional strategy that you could use to leverage that core mechanic? And when would you use that strategy? And it's a very readable, short chapters kind of book.
Great, thank you.
Sure.
Well,
my dean will be glad I'm plugging his book.
Well, we are out of time. Thank you, Candace, for sharing your perspectives, and really a challenge in a way to some folks maybe in our audience. But thank you again for.
Sure. Bye.